Okay, so this is going to be our third and last video of day 9 of Unit 4 in geometry. And in it, I'm really going to talk about one thing more than anything else. But first, I'm leaving it on this screen just in case, for whatever reason, your formula chart is terrible. As far as volume works, right, you're going to need to know these formulae here. And really, it's 1, 2, 3, 4, 5, 6 formulas in 4, right? Because of what we talked about in the first video relative to day 9, right? These two, or rather, prisms, cylinders, and pyramids and cones are, essentially the same thing, whether we're talking about surface area or volume, right? But then you've got spheres and Platonic solids, right? So spheres is another instance where I can't really go into what is it relative to without using calculus, and even then it still would be hard to get the point across. Okay, and then you have Platonic solids, right? And the interesting thing, the reason for this last video is right here. Platonic solids have a radius, right? So the radius of the polyhedron, right? AKA, in this case, we're obviously talking about a Platonic solid. So let's talk about what we mean. So obviously we know N of F means number of faces. A of F means the area of each face, right? 1/3 is a constant 1/3, or basically dividing by 3. But real fast, let's talk about Platonic solids and their radii. So the radii of a Platonic solid simply comes from the fact that because they're Platonic, right, because they're special in that way, you literally can put a sphere inside them, and that sphere will be tangent to each one of the faces on any given Platonic solid, right? And not just tangent, in however way, tangent to the centroid. So here, this sphere within the cube, right? We know the number of faces on a cube is 6. This sphere within the cube is tangent to all 6 of its faces, and it's tangent at every one of the centroids, right? So if I draw, there's one radius, there's another radius, there's another radius. Excuse my crappy drawing, right? So that's what we're talking about when we say the radius of a Platonic solid, right? So the radius of a Platonic solid is simply from the symmetrical center, if I can spell, symmetrical center of Platonic solid to centroid of one of the faces, right? One of its surfaces, okay? So this right here is a dodecahedron, right? So this guy has 12 faces, therefore it has 12 centroids, therefore it would have 12 radii, okay? This guy is an icosahedron. That means it has 20 faces and therefore 20 radii, right? Because this sphere would be tangent all over the place. Here, 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 and I mean, I could just keep going, okay? This is an octahedron, even though this rendering of it is horrible looking. And trust me, it was really hard, believe it or not, given this day and age in the internet, it was really hard to find renditions of Platonic solids and their spheres, right? Their inner spheres. It sounds like I'm talking about like some kind of a Mortal Kombat superpower. But anyway, this is an octahedron, even though it looks horrible. It's an octahedron, so we know it has 8 faces and therefore 8 radii. This is a tetrahedron, my favorite, and it has 4 radii because it has 4 faces. Okay, so that does it for this video. This video, like I said, was really just about answering this EQ and or getting you guys to copy this down if it's not in your formula charts. Otherwise, that's it. If you have any questions over the radii of Platonic solids, you know where to find me or shoot me an email. Goodbye.